I did not record this. Okay, so this is our distributing. Forgot to start recording it. Here are some examples. We'll go do number 5 on the next slide. Does anybody have a question about number 4? You already kind of knew how to multiply x times 2x, right? And get 2x squared. So you know how to do the pieces of this. It's just putting the pieces together to do something a little more difficult. If we had 2y times 3 plus 5y. Okay, so does anybody want to tell me what they got for that one? Anybody want to volunteer? 6y plus 10y. Anything you need to add on that y? How many copies of 2? You got 2 copies of the y. Some people do this, and I don't know if any of you need to do this, you can. I never have shown it this way because most of the time people, by the time they get to this, have multiplied stuff enough that they're comfortable with it. But here's what you could do. This is kind of an organizer, I guess you'd say. And you'd say, I'm multiplying 2y times 3 and 5y, and I'm going to add all this together since it's a plus. I'm going to put a positive 5y. 2y times 3 is 6y, and 2y times 5y, 5 times 2 is 10, y times y is y squared. Now let me move into something a little more, I don't know if I should, well, it's so hard to tell you. This is so important in math. Here's what usually happens. Let's say I have x squared plus 2x. We learned in Algebra 1 that if we can break this apart the way they were before, I can actually find the answer to this. So, if you look, we're going to undistribute here. We're going to do something that's called factoring. And factoring is the same thing. If this is not a real math word, can't even read factor there because I am not getting it to pick up well. Let me get a bigger marker here. Factor. It's kind of, this is not a real word, but you could call it undistributing. Okay, is one way to look at it. That's really what you're doing here. What could you divide out of x squared and 2x? What would divide into both of them? Well, the 2 up here, x, right? I could take an x out of both of them. So what I do when I factor is I undistribute. I say both of them can have an x taken out of them. So now this is the greatest common factor out here. And now what I'm going to do is I'm going to put my leftovers inside. What is left over when I had my x squared and I divided the x out? I don't think I have all your attention. Well, if you think about x squared, isn't it xx? And if I divide an x out, one pair of x's would cancel out. I have x left. You can always do that. If you get confused, you can say division is like a fraction bar. So if I make a fraction and put x squared is xx, and then put the x on bottom, they cancel out, I would see that I have an x left. That's the leftover when I divide the x out, right? I could do the same thing on the next term. If I have a plus, I could write down a plus. What is 2x? Divide the x out, and remember, you could write it like this. If I divide the x out here, what's left? 2. You just factored. When you did that, that's one way you factor. Now, there's a whole lot of different forms of factoring. This is one form, but it's the first form you usually learn. And you take the thing out that they have in common out front, and then you put what's left over inside. Now, this looks like what you did on that page, doesn't it? It looks like you would have had this, and you would have multiplied it out. You can always check to see if you did it right by multiplying it out. X times x is x squared. There's the plus sign, and x times 2 is 2x. So this distributing is the opposite of what we call factoring. Let's do some examples like that. Let's do 3y minus 18. What could you divide into both of those terms? 3. So I'm going to take a 3 out. That is the greatest common factor. Remember, the greatest common factor is the biggest thing that divides into two things, isn't it? What would be left out of 3y if I divide the 3 out? Y. See how that works? And then there's a subtraction sign, so I could copy it down because I don't have a negative out front, right? What would 18 divide out 3 be? 6. Huh?
I said 6.
Oh, okay, 6. There, you just factored it. You have the GCF out front and the leftovers. The problems you got today looked like that, though, didn't they? They looked like 3 times y minus 6. And you said 3 times y is 3y. And 3 times negative 6, remember that's one way we can do it, would be negative 18. So you see how these undo each other? One is the opposite of the other one, kind of, isn't it? Okay, so this is a process you use to find your solutions when you get into Algebra 1. Doing some of those easier problems so that you could actually see how you can start getting answers when you have squares and stuff on some things. Let's look at number 1 under the box next to that one where it says stretch. Let's work through number 1 together. Do you see the boxes right above that box, by the way, that shows the little organizer that they did for the distributing? If you look at your paper, the top box where it says memory on the right-hand side, that's showing you how some people will draw boxes to do that. Now, if you're like me, I don't want to take the time to draw a box because it's like too much work, too much writing, you know. I could, though. I could say 3, and I could put x plus 7, and I could do this. And I could say 3 times x is what? 3x. But it's easier for me just to go 3 times x is 3x. Okay? Now over here I could say 3 times positive 7 is a positive 21. But I could also go 3 times positive 7 is a positive 21. I don't like drawing the box because I just don't want to take the time to do it. It's just faster if you don't have to do it. And you want to, if you do have to draw the box, it's okay, but you don't want to be doing that forever because then everything you do from now on would just take you forever. But it's a good organizer if you need something. And you might sometimes. Let me show you another kind of distributing that you do in Algebra 1. Weird. Let me show you how it works though. What if I had this, x plus 4 times x plus 5? For you to understand what's going on here, the boxes really do help. What if I were drawing my boxes? I'm going to kind of split them up like this. What if I put x plus 4, x plus 4 and I'll just keep the same color, x plus 5. Now you can see how the boxes might help you. X times x in this top box on the left would be, what is x times x? X to the power of 2, x squared. X times 4 would give me 4x. That's the top row there. On the bottom row, 5 times x would give me, and 5 times 4 is 20, right? Now, I'm really supposed to add all this stuff together, so these two terms usually end up adding together when you do this. What would 4x and 5x be? Huh? You're adding here. You're adding, and I'll show you why in a minute, okay? 5x and 4x would be 9x altogether, so let me just combine them and put 9x over here so I remember that's what I got. My answer here would be this x squared, and it would be that 9x, and it would be that 20 all added together. So sometimes when this is distributing still. Didn't I multiply? Let me show you how it works if I don't use the box. That might be more helpful. So when I get 2 parentheses in a row, normally I would just cover up the what we had been having was something that looked like this on the other problems today, right? It just looked like that. But now instead of one thing out front, there's 2 things in that first parentheses, right? So I just have to distribute both of them. I'm going to say x times x is x squared. X times 5 is 5x. And so I distributed the x. Now I'm going to go distribute the 4. Okay? So you do one thing at a time. You start with the first number and you distribute it in the second set of parentheses. Now I'm going to distribute the positive 4. What is positive 4? I'm going to draw my little things underneath it just so it's not so messy. What's 4 times x? 4x. What's positive 4 times positive 5? Positive 20. I have all the things in the box down here, don't I? If you look, there's the x squared, there's the 5x right here, the 4x was here, and then the 20 was here. Don't I have all the same terms? What do I have in between them up here that I don't have in the box, though? The adding. So yeah, that's why sometimes the box is helpful, but when you do it this way, you really see that you're adding it all together. So if I add the like terms, aren't the like terms this 5x and this 4x, right? That would be the 9x, right? Okay, so I could say, oh, that adds up to 9x. I'm just going to write it right here for a minute. If I write my answer there, it would be x squared plus 9x plus 20. And then I can undistribute that. We're going to wait. We're not going to talk about that on this video today because that would probably be, you probably already are like, oh my gosh, what did she just do?